A very good morning, good afternoon, good evening to all the participants and the candidates for this NPTEL course, title of which is Application of Forecasting Regression and Time Series Model. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, as you can recall, that there are, even though I am repeating, please excuse me for that, it's just to keep a sync of all the discussion which we are having for this 30 hours course, which as you know is spread over 60 lectures, each lecture being for half an hour. So, the three main topics are averaging techniques and forecasting, the second one is regression models, under that different models will be considered, and the third one being time series analysis. So, this is the third lecture in the second week, which is the 8th lecture, and we continue discussing the ideas about averaging techniques and forecasting. So, what is the coverage for this course? The coverage for this lecture would be, we will consider distribution of errors and we will plot those errors. We will consider the example of the examples of distribution of errors, again with as needed. We will consider example of forecasting using mean squared error and go into details, start in the idea of about weighted moving average, which will continue for few lectures at least. So, considering the forecasting prediction intervals, which we are considering further on. So, prediction intervals are usually based on mean squared error. If you remember in the last class, and why I am going back to the last class, which is the 7th one, we did discuss about different type of predictions and the idea of forecasting. One was the concept of the point estimation, which we are going to do, and the other idea was basically trying to find out the interval, and the interval, if you remember, we have drawn the normal distribution, the skewed left, skewed right distribution, and trying to find out that given an interval which is fixed in the normal case, how the total area of coverage considering the skewed left or skewed right distribution would be different. And I have shown it pictorially. Even though calculation part would not be required, we will consider that in a very simple way later on when we come into the ideas of regression models. And that idea can also be utilized in the forecasting model. There is no such a hard and fast rule that the interval concept wise, which we are going to utilize in the regression cannot be utilized in forecasting, or which is being utilized in forecasting cannot be used in regression. So, further discussion being continued is, I will read it again. Prediction intervals are usually based on MSE, mean squared error. And if you remember, the mean squared error concept was time and again mentioned and highlighted, considering that you are able to minimize the variance, which is very important. Even though one flip side is that as it is square, for any outliers it basically gets double in the sense. So, if it is 2 it becomes 4, and in the case for 100 it becomes 100 into 100. So, it increases by square. I will not use the word double. So, because it provides an estimate of the variance which I mentioned and is one step forecast error in a very nice way. Now, the prediction of the interval can be written as, and I will write it down in more details here. So, if you consider the idea of the prediction error, it is given by f n plus 1 plus minus k into the mean squared error, and this is what is important. If you can recollect how the normal distribution looks like, was like this. This is the x axis, this is the y axis. I will erase it when we read it. So, this would not be confusion. And if you consider the distribution normal being this and the intervals which were given is, consider this. So, here the mean value is actually the mean, which is mu m, but we are trying to find out the interval with respect to the f t plus 1, the next value, and what are the variance, because we are predicting the next value standing today using any model, and that next value which you are predicting, considering one step forward we are moving, is given by f t plus 1. Because we are standing at t time period, we are trying to predict for t plus 1. That is why it is the mean value rather being considered, we will consider f t plus 1, which is the forecasted value for t plus 1, and based on that we are trying to find out the error. Now, this being f t plus 1, there are errors. Now, the errors would be considered, I will highlight it for the right side of the error and the left hand side of the error using the same color, but it is green, just to differentiate that. So, this is for the right hand side and this is for the left hand side. Now, for one standard deviation, we will consider that 1 is given by square root of mean squared error, because mean squared error technically would be the variance. So, square root of that is the standard deviation. If I am considering just, I think I have overdrawn something, this part here. So, this is the part. So, I will mark it in more details. So, the extract error is given. So, this is the right part. So, a little bit more shading in all the areas which are unfilled will make the idea of the error absolutely clear. So, this is the right hand side, and when I consider the right hand side, it will be plus. So, that is why the plus and minus sign you are considering the plus. So, that is the first point. Now, what is k? K is the number of times. So, if it is 1 standard deviation, k is 1, it is 2 standard deviation, is k is 2, it is 3 standard deviation, k is 3. So, based on the idea of level of confidence, you will basically fix the value of k. So, here comes k for the right hand side. So, if it is 1 standard deviation, if you remember, the total coverage of the area over and above the mean is about 67. So, for 1 standard deviation, it will be half of 67, which we will consider as about 67 would basically be about 33 approx. So, 2 standard deviation would be 33 into 2. So, if I consider the total coverage in the sense for 2 standard deviation plus minus 1 standard deviation is 2 standard deviation is about 67, plus minus 2 standard deviation, which is 4 sigma, would be about 97%, and plus minus 3 sigma, which is 6 sigma, would be about 99.9%. Now, when I come to the left hand side, so the overall coverage area is this, which I am now highlighting on the left hand side. So, again if it is 1 standard deviation to the left, so this k remains 1, square root of MSE remains as it is, only the sign is minus because you are not the left hand side. So, plus minus is basically coming from this, and remember this is f t plus 1. So, even though it is given is in the formula as f n plus 1, technically it is f t plus 1. Now, one important thing to remember for that error are the important assumptions, and they are also applicable for the regression models. So, even though I am repeating it time and again, so we will here, but again we will consider that when we are considering the ideas of regression. The number important point is the expected value of the error is 0, because any fluctuation in the error you have in the long term, it will be 0, because plus deviation, minus deviation, plus deviation means where you have the, if I am trying to find out the difference between the actual value and the forecasted value, then the forecasted value is less. So, hence the deviation is positive. If I consider forecasted minus actual value, it will be negative. So, in one case the forecasted value can be more, in another case it can be less. So, if I basically add up all the errors in the long run, it should be 0 as it is right intuitively. Number 2, We will also consider for the regression model especially, and also for the forecasting model, even though in forecasting model we would not be highlighting it to that extent, but the variability of the variance of the errors is fixed. So, it is not fluctuating. But when I come to the ideas of time series analysis, we will consider the variability of the errors is fluctuating. Hence, the ideas of autocorrelation and all these things would be heteroscedasticity, homoscedasticity, trying to basically find out the lags, and all these things would be dependent in time series, even in a much more detailed analysis, even though the idea of lag was considered in the forecasting model. So, again, and the last one is, which is a very restricted assumption which can be relaxed, is the idea that the variability of the errors is normal distributed with zero mean, as already discussed, and this error terms would have a variability or the variance which is given by VET. That is basically being signified by this sigma square suffix E. E is basically the error. And the idea normality which I have already discussed, I am using a different color, is this one. So, these three assumptions are important, even though the first and the second are more important than the third one, where you are considering it as normal distribution. And we will consider that using the diagrammatic representation. Now, these data which are used are actual data for Tata Steel NSE price from February 2012 to February 2014, even though it is old, but still the idea, basic idea about normality and non-normality would be very clear here. Now, we are taking the Tata Steel price only. Now, many of you who are aware of finance, you may answer that why we are taking price, why not the returns? We will consider that within few minutes. So, if I consider the price, there are two normal distribution which I have shown, and I am going to highlight it using two different colors. The first one is here, which I am circling with orange. The second one is basically which I am circling in green. What is the orange one? Orange one, if I plot only the distribution, this is the histogram plots. Histogram plots for the Tata Steel price. So, obviously, if you see more from the point of view of forecasting, people will be interested to find out what is the trend, what is the variability. Considering the variability, I am using the normal distribution in order to basically highlight. So, distribution can be anything for the variability, we will see later, and we have already seen the distribution in the last class of skewed to the right, to the left. So, this I just drew in order to basically highlight how the variability is. Now, if I plot the histogram of this actual data, this is given by the one which I am putting a tick mark is using the orange one. Nowhere it is normal. And the other distribution which has been marked in green is basically the distribution which we will see later on for one of the metric based on which I am trying to find out using the Tata Steel prices for NSE February 2012 to February 2014. So, this is not normal. When I go to find out the Tata Steel NSE percentage price with respect to the mean for the same time period February 2012 to February 2014, and what I mean by the mean is basically I try to find out the differences of 2 days, because I am only considering either here, I will come to that. You can consider either the opening price or the closing price or the maximum price or the minimum price. I am only considering the opening price. So, I can do the similar analysis considering the closing price, maximum, minimum. And if I consider the percentage price with respect to the mean, what I am considering is I will use the red color. So, this I am considering the price of T plus 1 day, which is say for example of today, minus the price of 1 day before divided by the price of 1 day before. So, if I find out the price with respect to the mean, so Another concept would be that word mean is being utilized for another sense. Actually, this would basically be given as the return. Another way we are finding out the return would be simple one, which I am using the green color to highlight, is basically find out PT minus the expected value of all the P prices which we have. So, basically I will try to find out this one, difference in the price of today or whichever day it is with respect to the mean value divided by the mean value. So, I am trying to find the fluctuation with respect to the mean, which is shown in green one. Red one is basically trying to find out the rate of change of the prices with respect to the last value. So, last value means if I am trying to find out for t, so it will be based on t minus 1 divided by t minus 1. Here I have just utilized the time concept as t and t plus 1. So, that concept does not change if I replace t with t minus 1 or if I replace t plus 1 with t. Now, if I plot the values of R, again the one which is being shown in the green highlighted one, circled one, is basically the histogram plot for the actual data which is plotted here, which is nowhere near to normal. And the one which I am highlighting here using the orange color is basically the one histogram which is normal. Continuing the discussion about the plotting, here is basically now an interesting thing. Here I am trying to plot the percentage change which is based on the fact of the rate of change, which I had marked in red. So, R was basically PT plus 1 minus PT divided by PT. And if I plot it, the fluctuations, if you see very carefully, the mean value in and around, I will not use the mean value, in and around the value where the fluctuation is basically 0. And if I plot the distribution based on which I have plotted in the diagram here and which I am just circling with the red color, this is basically almost normal. Now, the question you may ask is that we were discussing about the error mean value, error variance and distribution of error. Why we are drawing it for the return? The reason being that we will come back to the return, but the idea or come back to the mean, my apologies, but the idea of the return for this type of time series data is very important, because that gives you an idea that how the return values also changes, considering the returns are given by this formula as marked in red, and how the mean value changes. We will highlight that using the examples later on. So, but I thought that rather than trying to utilize any error, and the error would basically come out from the forecasting model. So, as we proceed with the forecasting models, we can use the errors based on any forecasting model, then try to plot it and see how the distribution would look like. But this being an actual data would definitely give you an idea what I mean by the mean value being 0, what I mean by the variability being 1, and how it can be utilized using some other examples where the returns are important, and then basically try to extrapolate those ideas of mean value being 0 into the case for the errors terms also. So, now we will consider an example, and if you see that for each example the example number is given. So, this is the 8th example. So, what do we have? We have the serial number which I am considering as the time period. So, time period can be either in months, weeks, days, years, quarters, semi-annually, whatever it is. So, I am marking the columns accordingly. So, I will use the green color. So, serial number is the first, the second one is the amount, third one is basically, third and fourth one is basically the value of y, and based on that we find out the errors. We will come to that. The fourth one is basically again another value of y based on which we find out the errors. Fifth one is basically again the value of I based on which we find out the errors, and this is what we are doing. Based on the amount of in rupees which is given starting from 2900 in rupees till 3001, what we do is that we basically find out its mean squared error and the squared sum of the errors, and these values are given for both the third column, fourth column and fifth column, and what they are is like this. Why we are taking the value of the third, fourth and fifth column as y hat to be 2900, if you can see it, then to 3000, then 3200 is based on the fact that given this second column, which is the amount, we first basically find its average value and then try to find out with respect to the average value what are the errors if we had taken not the average value but the value of 2900, that is for third column. Similarly, for the fourth column, rather than taking the average value, what is the error and the square of the error and the average of that, based on the fact that we take the y hat value as 3000, as you can see in the fourth column. Similarly, for the fifth column, rather than take 2900, rather than take 3000, what would have been the error and the square of the error if we had taken the value of 3200, and why we are doing that, we will come to that later. So, considering the values of 2900, the first column of the third column, which is marked here, which I will use a different color for the time being as dark red. So, these are the errors. So, 2900 minus 2900 is 0, 2900 minus 3200 is minus 300, then 2900 minus 2500 is plus 400. Then considering that if we continue, 2900 minus 3100 is minus 200. We square it, which is given in the second column for the third column, which I will mark with a different color, which is violet, and the error square as a given. Based on that, when I find on the mean square error, then the sum of the square of the errors, the sum of the square of the errors would be just the summation, and the mean square error would basically be the summation of the sum of the squares divided by the total number of reading. Now, continuing the same discussion, I will remove this color for the column 3. If I continue the discussion, I have the errors for when I consider y hat at 3000, 3000 minus 2900 is 100, 3000 minus 3200 is minus 200, and I continue to the last values 3200 minus 3100, 3000 minus 3100 is minus 100. Then basically I find out the square of the errors, which I just highlight with the violet color, and the bottom row I find out the mean square error utilizing the sum of the square of the errors. Sum of the square is errors is basically addition, and mean square is basically dividing the number of readings, which is 12 here. Now, what is important is I'll mention it. The mean square error for y hat is 2900 comes as this. I'll use the yellow color. Comes as 267500. For the value of y is equal to 3000. The mean square comes out to be 255833. And if I continue doing the same calculation as I have done for the third and the fourth column, I would highlight that for 3200, the errors are 3200 minus 2900 is plus 300, and similarly if I consider 3000 minus 3200 is 0, and the last value is 3200 minus 3100 is plus 100. If I find out the square of the errors, which is what I am highlighting with the violet one, and when I find out the sum of the square of the errors, based on that I find out the mean square of the errors. The mean square errors for y hat is equal to 3200 comes out to be 292500. So, if you see the mean square errors for y hat 2900 is 267500, for y hat is equal to 3000 is equal to 255833, and for the last value 3200 is 292500. Now, what I do is like follows. I consider all the different values of y hat. So, what are the y hat values which I am considering? I will mark them in yellow. So, starting from 2500, 2550, 2600, and it continues in the first row till the value of 3000. I continue In the third row, 3550, 3100, 3150, 3200, and it continues till 3550. For each of them, I do the calculation and find out the MSE. MSE means basically find out the errors, square of the errors, sum of the errors, basically gives you the sum of the square of the errors, divided by 12 gives you MSE. The MSE values for them are as follows. For 2500 is given as 514166.7. For 2500 as y hat, the MSE value is mean square error value is 465833.8, and correspondingly the second row gives all the MSE values for y hat values starting from 2500 to 3000. Similarly, the last row gives us all the values for MSE starting from 257500 till the value of 549166.7 for all the values of y hat starting from 3050 to 3500. Why I do that is this: I plot them. When I plot them, I find out the curve where along the x axis I have the y hat values and along the y axis I have the mean square error, and it looks a very nice squared error function or squared error loss, from which I can immediately plot a vertical line for which my total mean square error would be minimum, which means the forecasted value which I will try to utilize for that data, for the 12 datas, the average value or whatever the value which I am trying to find out. Here I am not marking it, but you can find out that the average, the value where the minimum square error will be minimum, which will give us the best possible forecasted value for all these 12 datas which can be utilized such that we are sure the mean squared error would be minimized. And the question may immediately come from your side is that, what if we consider the mean absolute error? Would we get the same value? Answer is no. We will get a different value. The other question can be, would we get the same value if I use the percentage error or absolute percentage error? The answer is no. We can get two different errors. So, the next question can be that what happens that if we use the U statistics or MAPE or the mean absolute error, the answers can be different? Answer is yes, they can be different. Then the question can be, what value should we use? That will depend, as I keep saying, would depend on the model which you are trying to utilize. So, we will basically start a precursor about weighted moving average. Weighted moving average would be, I would not be going to much of the slides for this class at least, but it will continue in the next class. Weighted sum concept basically means you are giving some weightages based on the models you are going to consider. Now, closer the value is, more weightages you will give, further the data is, for the more less weightages you will give. That is the thumb rule, and which is very intuitive. Now, another question may appear is that, do the weightages change or can they be changed? The answer is yes, they can be changed, and there are methods we will try to consider that how the weights can be changed. So, without going into much more details, we will basically end this class and continue in more details about the moving average concept in the later class. Thank you very much and have a nice day.